Hi everybody, today I'm going to be doing a tutorial on um, how to solve problem 3 for homework 5 in our aquatic chemistry um, class. The goal today is to basically come up with a solution via Excel, um, and I'm showing what sort of the final product is going to look like, um, and what our plot is going to look like at the end. The idea of the video is to be able to solve this problem using just Excel, with no prior experience of using Excel. So if you have experience of using Excel, just look at this window and this kind of gives you a picture of what you're supposed to do. Um, but if you have never used Excel before, you can still watch the video and get a sense of what you need to do. Okay, so the problem that we're given is number 3. It says for a 1 times 10 to the minus 3 molars solution of Na2S, find the pH at equilibrium, and it also asks to determine um, what species is larger, or what species concentration is larger at equilibrium, HS minus or S2 minus. We're given that the pKa1 is equal to 7.1 and pKa2 is equal to 14. This question was kind of confusing because Na2S forms H2S in water, and H2S separates or speciates into H2S, HS minus, or S2 minus in accordance with the pH of the water. So even though we're given this Na2S, our concern is H2S, HS minus, and S2 minus, which, like I said, changes with pH. So given this concentration, we need to find the pH that this solution is going to be in when it's in equilibrium, given the pKa's. Another clue that we need to talk about or think about H2S, HS minus, and S2 minus as opposed to this Na2S is that these pKa values correspond to the formation of HS minus and S2 minus. So that's another clue right there. Okay, so to solve this problem, we're going to open up Excel. This is my finished sheet, but we're going to open up a new one. We're going to start from scratch. We're going to an even newer one. Let me do something. Let me move this over here. And let me move this over here too. Okay. Basically, we're given again Ka1 and Ka2 values, or pKa1, pKa2 values, and the total concentration of the Na2S, which to us is basically the total concentration of sulfur that's going to be divided into H2S, HS minus, and S2 minus concentrations. So the first thing we need to do is write our equations. So you can just write the word equations into the cell, and you can hit Control B to bold it if you want to make it look a little nicer to stick out. We know a couple of things. Well, basically, these equations are going to be used to set up our mass balance and our charge balance conditions, which are necessary to solve the problem. The pH at equilibrium um, is the equilibrium pH when the mass balance conditions and the charge balance conditions have been met. Until both of those have been met, the solution is not in equilibrium. So that's the definition of equilibrium. Since that's our definition, we need to set up equations that follow those definitions so we can find an answer. Okay, the first thing I always like to write is, just to remind myself, is that our Kw of water, it's equal to, and you can just write equal to, it's just equal to H plus the concentration of H plus times the concentration of OH minus. and that is equal to, and you can write here equal to 10 raised, this little up arrow is raised, and parentheses to the minus 14. So that's always true. It's just a good reminder. We're also given Ka1, and we know that Ka1, excuse me, Ka1 is equal to HS minus times H plus all divided by, to make the division sign, you have to hit this apostrophe sign and then hit your slash. If not, Excel won't take it. All divided by H2S. And that value is equal to, it was given in the problem statement. Well, we were told that our pKa1 is equal to 7.1. So that means our Ka1 is equal to 10 raised to the minus 7.1. And Excel will calculate that for you. Done. Okay, similarly, we can have an equation for Ka2, and I'll just copy paste that one. Right? Ka2, pKa2 is equal to 14. That means our Ka2 is equal to 10 to the minus 14. And to verify, if you want to verify that you did that correctly, you can just type in P of Ka1 is equal to, and then you give it a formula, is equal to this value. So I guess this is an introduction to formulas, but you type in equal to, and you pick the cell that you want to evaluate, and you just so you write it's equal to the minus log. That's a function. Once you pick the function you want, you select it. You want to take the minus log of this number. Close parentheses, hit enter, and that gives you 7.1. So you know you entered this value correctly. The same thing applies here. If you drag over these cells and hit Control C, and then go one cell lower, hit Control V, Excel will actually copy the formula one cell down. We just have to change this to pKa2. So okay, our values are correct as given. We also know that the S total, the total sulfur in solution is going to be spread into these three species that we see here. It's going to be spread into the concentration. A little bit of sulfur is going to go into H2S, a little bit is going to go into HS minus, and a little bit is going to go into S2 minus. So we have an equation for that. That says that S total is equal to the sum of their concentrations. And that was given to us as 10 to the minus 3 moles per liter, right here in our problem statement. Okay, so we have that equation. Based on these three equations, I almost forgot our charge balance. Our charge balance is going to be basically all the positive ions should be equal to the concentration of all the negative ions, and that's expressed by this. H plus is equal to HS minus 2 times S2 minus, because of the charge is 2 times. There are 2 electrons here, so you need to multiply it by 2, plus OH minus. So that's not going to really do anything for us besides just reminding us that this is the case. This needs to be satisfied for equilibrium to be reached. Okay, the part of the point of doing all this is that we have solutions, or we have equations to express um, our concentrations of H2S, HS minus, and S2 minus, um, express those concentrations in terms of all the other variables that we have here. And so um, you can actually type in, I find it helpful to type in a formula. It's not going to do anything to Excel, it's just a formula that I can view, an equation. And to do that, you go to Home, Insert, and then Equation. You can pick any one of these and then just edit it. Okay. And so now you have a box in which you can type anything you want. And so if you do that, you can type in equations. I already have them somewhere else, so I'm just going to copy them in. Our first equation is right here. That's for H2S. Our second equation is right here. That's for HS minus. And our third equation is right here. That's for S2 minus. These equations were given by Dr. Greenfield in class, so I guess you're expected to know these. But these are just for our reference. It'll help us out later. So after we have an equation set up, we have our equation set up, we can set up a table. We're going to set up a table, and our table is going to have, the column headers are going to be pH, then the concentration of each component in the solution. So our first component is obviously H plus, it's always going to be there. Similarly, OH minus will always be there. And now we have our three, in this case, 3 species because it's diprotic, the compound we're looking at. We're going to have H2S, HS minus, sorry I did that wrong, HS minus, and S2 minus. Okay. You might have seen my goofy little drawing when I started the video. Our goal is to draw a pC-pH diagram. Basically, pH goes, it's 2 axes, and pH goes on the x-axis positive in the right direction, and pC, which is equal to the minus log of the concentration of each species, goes positive in the y-axis downwards. We want to draw a graph that looks like that, so we're going to need to take the P of every component of every species that we have. So we're going to have to take the minus log of every concentration. Okay, so we're going to, I'll save us time. I'll just copy it over from this sheet. You can just copy just the values. Okay. So now we have a P of OH, P of H2 minus, P of HS minus, and P of S2 minus. We already have our P of H over here, so we don't need to repeat it. Another thing that we're going to want to check is our net charge. Our net charge is going to have to be equal to 0 wherever the pH is whenever the solution is in equilibrium. So we're going to have a bunch of values across this table, and wherever you see a value of 0, that should tell you what the pH is at equilibrium. Then you should be able to go on your pH and pC diagram and see what's happening there, and it should all sort of coincide and make sense. Okay, so our pH column we're going to fill in, and we can fill it in with by going by any increment that you want. I choose to go by 0.5 increments, so that way I don't take up a bunch of space. 1.5. In Excel, if you choose these 4 cells and drag this little button down, it'll fill in the rest of the cells for you. Okay. All of the remaining cells columns will be filled in using formulas, so we're gonna have to fill those in automatically, or we're gonna have to fill those in one by one, is what I meant to say. H plus, concentration of H plus is equal to 10 raised to the minus whatever value we have in this cell, right? Similarly, OH minus, because of this equation we have in row 2, is always going to be 10 to the minus 14 divided by H plus, the concentration of H plus. So we can put that in. So we're going to say it's equal to 10 raised to the minus 14 divided by the concentration that we have in this cell. We just click on it. Maybe I did something wrong. Nope, I did it right. Okay. H2S is going to be equal to, it's going to be, we're going to have to program it, or we're going to have to insert the formula that we wrote right here, but in a way that Excel will understand. So we're going to say that's equal to S total, which is here. We're going to want to lock that value. So we're going to put $, because we're going to drag these values down to fill in our table. And when we drag it down, Excel will drag down every value in the formula. We don't want it to drag this down. So $I, $5 means to reference this value right here, I5, and it will always value that, whether you copy paste this formula anywhere else. Okay, so it's the S total times, open parentheses, H plus squared. So we're going to get this value, whatever's in this cell, and raise it to the second power and close our parentheses. This one we do not have to lock because we want it to get dragged down as we drag this formula down. If you don't understand what I'm saying, you'll see in a second once I fill in this whole row. Okay. And then this huge denominator. So again, this is going to be, we're going to open two parentheses, one for the H plus and then one for the denominator. This value squared plus Ka1 we're going to put $ so it doesn't get dragged down. I clicked out. I have to go back and fix it. Okay. Ka1 times H plus again, plus, oh, I picked the wrong one. Okay, that's not supposed to be, I picked Ka2 instead of Ka1, so let me fix that. I'll just change this 4 to 3, and now it knows I'm talking about that. Plus Ka1 times Ka2. This is my Ka1, I just copy pasted it, and times Ka2, I'll copy paste it again and change this to 4. Okay, so Excel will show you in colors what cells you're referencing, and I'll check that. Every time I write a formula, I check it because it's harder to go back and check if your formula is right after you've already written it. It's easier to just check it while you're writing it. So H2S, this is the H2S column, is equal to S total. S total is right here, so it's in blue, that's correct. The $ means it's locked, so it won't, even if I copy paste this formula, it won't move that value, it'll always reference this value. Times H plus squared. So this is in red, this red cell squared perfect, divided by, I open two parentheses, one for my H plus, so it's in red squared, so that's correct, plus Ka1, Ka1's up here, this purple, lock times H plus, the red, plus Ka1, this is in purple, times Ka2 in green. Okay, So if I hit enter, that should give me the concentration of H2S at pH equals 0, which is just for graphing purposes. Okay. Or okay, so now we can start filling in this cell for H2S. It's gonna be similar to this one, but so go ahead and say H2S is equal to S total right here, and I'll lock it. Let's see if I can hit F4 if it locks. It doesn't do it. Let's see. Well, nope, doesn't do it. On your laptop, you might be able to hit the button F4, and it'll do that for you. But I can't seem to figure it out on my desktop. Times Ka1 this is locked again, so we have to, or at least I have to manually put in these dollar signs, times H plus squared. This squared. We'll divide it by the same denominator that we have here. It could also be helpful to define a column with just the denominator, so you don't have to keep typing this in every time, but we'll just type it in. So it's just my H plus squared plus my Ka1 times my HS plus Ka1 sorry, I had a dyslexia moment there. Ka1 times Ka2. I'll close my parentheses, hit enter. Okay, and what I'll do for the next one is I'll just copy the denominator because it's the same one. I'll just copy that text. Okay, S2 is just equal to S total, and that's locked times Ka1 locked times Ka2 locked divided by, and I already copy pasted the denominator. Okay, our pOH is just going to be equal to the minus log. We want log base 10 of the OH column. And actually we can drag this to the right and it'll already know what we want. It'll take the minus log base 10 of the next column and the next column and the next column here. Okay, our next charge, our net charge, excuse me, is going to be, this is our charge balance. So we have H plus is equal to all the negative ions. If we move our H plus to one side, then that's our net charge, right? If we move our H plus to one side and we have more H pluses than negatives, then our net charge will be positive. So, you know what, I'll do that here. So we know that 0 is equal to HS minus plus S2 minus, 2 times S2 minus plus OH minus minus H plus. And that's what we're going to put right here. We're going to say that this is equal to, sorry, I'll say that this is my net charge. my net charge is equal to that. Okay, so my net charge is equal to HS minus plus 2 times S2 minus plus OH minus minus H plus. You can notice that H2S has nothing to do with this equation because it's not charged, it's a neutral. It's neutral, so okay. Now that we have all of our formulas set into this column or in this row 13, we can just drag them down. So to do that, you pick the center of this cell and you drag them to the right so that all of them are selected, and then you drag this little green dot down to 14. And it'll populate the table for you. So what you want to do is find give me 1 second. Okay. What you want to do is find where this net charge tends towards 0, gets very close to 0. What we can do is widen this column so that you can see the values. And it looks like it's getting kind of close around here. My formulas. In this HS minus, I squared the H plus in the numerator, so you don't need to do that. Okay. Now I can drag this down again and it'll fix my values. Okay. Now our net charge is you want to find where it's the closest to 0. And it looks like it's the closest to 0 wherever the exponent is the greatest number or has the greatest magnitude. In this case, it's around here. It's between here and here because our net charge goes from negative to positive. That means somewhere in here it hits 0. So we want to find that. What we can do is insert, right click to insert columns, and we can go by smaller increments. For example, we can go by 0.05, so 5.05. Once you hit enter, Excel will fill in the rest of the values for you. You'll see that this is an even smaller negative number, but it's not 0. So that means it's between these two values. Our equilibrium pH is somewhere between 5.05 and 5.5. So we can try inserting again. And since this is so small, it's very close to 0, we can try hitting using a smaller increment. Let's try 5.051. Okay. So I guess you're getting even closer. 0.06. That's already positive there. So it's smaller than that. 5.055. Okay. 5.052. So it's somewhere in between here. I'm going to say that 5.051 is close enough. This number is essentially 0. Okay, and if you want to be convinced of that, then we can plot these points out and see what happens at 5.051 or around 5. Okay, so our next step is to graph these values that we've tabulated so that we can get a visual representation of what's going on our spreadsheet. To do that, we're going to go to Insert, and we're going to go under the Charts tab or Charts section. We can go to scatter. This is the most useful way to do it. And I like to use scatter with smooth lines and markers. Excel will try to tab everything out for you, but um, you can just hit select data to get rid of that. So you want to remove basically all of them because Excel doesn't know what you want to do. We'll add one. And each, again, this is our pC-pH diagram. So we're going to assign the series name. Each one of these columns will get a series and will be plotted out. Our first one is going to be called pH. And the X values, again, our pC-pH diagrams looks like this. So the X values are always going to be pH, and the Y values are always going to be the P of the constant of the substance we're talking about. In this case, it's pH on both sides. So the X and the Y values will be equal. The X values will be these values. And like I said, the Y values will be equal. Okay. Something that we need to do right off the bat is to flip our Y-axis. So we're going to double click on our Y-axis and see if we can flip it. To flip, double click on the Y-axis. To flip our Y-axis, we'll just go under axis options and put values in reverse order, and it'll flip it. We don't want to flip our X-axis. So now we have our pH, PC sort of situation where we have X is going positive to the right, Y is going positive down. Okay. To add more data to the chart, just right click the chart and hit select data again. We're going to add a new series. The series name is going to be P of OH. And the X values, again, will always be the pH values. And the Y values will always be that of the column we're interested in. In this case, POH. I'm going to grab and do that. Okay. We're going to add another series. You can see our OH and our pH. This series is going to be called that. You can just click on whatever you want to call it. The X values again are the pH. H2S. Okay, we're going to add another one. You're going to do this for all the columns. That's not what I meant to do. Add. You can also copy and paste this and just change the A to K or to J. Now you have all your values plotted out. This is kind of crowded, so we can move it to a different tab. Move chart, right click, move chart to new sheet. And we're going to call the sheet pC-p lowercase pH diagram. Okay. And now our new chart, our chart is here. or diagrams here. We want to add um, stuff to this. We want to add axes titles. That would be helpful. So you can go up to the left, add chart element, axes titles, primary, horizontal. This is pH. Do it again. Vertical, this is POC. Something weird here is that it goes past 14, but we only want a max of 14 on either side. So double click on the axis options, and set the maximum to 14. Double click on the y-axis to do the same thing. That's not what I meant to do. Now you have your pC-pH diagram. So how does this help us on our problem? Okay, let me read what's going on here. You have pH in this dark blue going in a straight line. P of OH is in this orange. P of H2 is right here. It goes down. P of HS minus is in yellow. And P of S2 minus is in this light blue. If you want to change any of these colors, you can click on the data series and change colors here. Maybe I want to change this to green. You also need to change the markers to green if you want. Okay, so that helps. I didn't change the marker. I want to change the marker fill to green. Okay, that's better. According to this table that we had made, our pH of equilibrium is around here, and I'll highlight it. Hit home. Under font, you can just hit this yellow. Should be around 5. Actually, it's between 5.051 and 5.052, but those numbers are really indistinguishable on this diagram. So at 5, just about pH of 5, what's going on? Around pH of 5, it's right here. And you see our yellow line and our blue line are intersecting. So the pH is about equal to P of HS minus. It says our net charge is equal to, I'm sorry, I keep going to the wrong one. It says our net charge is about equal to 0. But there are still other concentrations that we see here, so what's going on here? Okay, our pH intersects with our HS minus line, meaning that their concentrations are about equal. But we also have this P of OH, I missed the minus here, this is an OH minus. So this is a negative ion, and this P of S2 minus. Notice though that there are about 1, 2, 3, 4 PC units in difference between the HS minus and the OH minus. That means they're about the difference in these values is about 4 orders of magnitude. So in terms of this net charge equation, which I'll bold, Control B. In terms of this net charge equation, this S2 minus concentration is so much larger than this OH minus concentration that this OH minus concentration can basically be ignored. I'm sorry, what I meant to say is that this HS minus concentration is so much larger than the OH minus concentration that this concentration can be ignored. Similarly, our HS minus is much greater than our S2 minus, as shown on the diagram, such that HS minus is roughly equal to H plus. Our minuses, our negatives are equal to our positives, and our net charge is satisfied. That indicates that this is our equilibrium pH, somewhere between 5.05 and 5.051. And I think 5.05 is a valid answer. You could even put just 5 as the equilibrium pH. So that kind of does it for this tutorial. Next, I'll be sharing how to solve this through a much faster way by Excel Solver. And again, it'll be another video where if you've never used Solver in your life, it wouldn't matter. You can still watch the video and check your problems on a test or get the problems for a homework. Okay.